Arrays explained, step-by-step introduction. An array is a data structure used to store multiple values of the same type in a fixed order. Software engineers use arrays for check storing lists of numbers, storing names items, coding interview problems, sorting, searching, two-pointers, sliding window, prefix sum, dynamic programming, matrix problems, backend data processing, API request, response transformations. A common learning topic is, how can beginners understand arrays step by step using Java? This guide explains array basics, indexes, traversal, insertion idea, deletion idea, searching, sorting, two-pointers, sliding window, prefix sum, frequency counting, 2D arrays, Java examples, debugging tips, common mistakes, interview questions, 30-day learning plan. Simple definition. An array is a container that stores multiple values using indexes. Example: int n nums equals 10, 20, 30, 40. Indexes. Value 10, 20, 30, 40. Index 0, 1, 2, 3. Important. Array index starts from 0. So, nums 0 equals 10, nums 1 equals 20, nums 2 equals 30, nums 3 equals 40. Why arrays matter? Arrays are important because many interview and real-world problems start with arrays. Examples: toSum contains duplicate, top k frequent elements, best time to buy and sell stock, maximum subarray, move zeros, merge sorted array, product of array except self, rotate array. Arrays help you learn loops, indexes, conditions, sorting, searching, time complexity, memory usage, problem-solving patterns. Array big picture array. Index 0, index 1, index 2, and end. Example: nums equals 2, 7, 11, 15. Nums arrow equals 2. Nums 1 equals 7. Nums 2 equals 11. Nums 3 equals 15. Array in Java. Create array int nums equals new int 5. This creates an array of size 5. Default values. Create array with values. Int nums equals 2, 7, 11, 15. Access value. System.out.println nums 0. 2. Update value. Nums 1 equals 100. Before 2, 7, 11, 15. After 2, 100, 11, 15. Array length. Use nums.length. Example: int and nums equals 2, 7, 11, 15. Systemout.println nums.length. Output. 4. Important. Last index equals nums.length minus 1. For size 4. Last index equals 3. Step 1. Traverse array. Traversal means visiting each element one by one. Using for loop. Integers nums equals 2, 7, 11, 15. For int I is 0, I equals nums.length, I++. System.out.println. Output. 2, 7, 11, 15. Using enhanced for loop. For int nums. System.out.println num. Use enhanced loop when get you only need value. Get you do not need index. Use normal for loop when you need index, you need update array, you need compare with previous / next element. Step 2. Problem. Find the largest number in an array. Input: 5, 3, 9, 1, 7. Output: 9. Java. Public int find max int elementary. Int max equals nums 0. 4. Int num in nums. If num is bigger than max, max equals num. Return max. Dot. Complexity. Time. O(n) space O1. Step 3. find minimum public int find min int nums. Int min equals nums 0. For int num nums, if num is min, min equals num. Return min. Step 4. Sum of array, public int, sum array int nums. Int sum equals 0. For int nums, plus sum equals num. Return sum. Example. Nums equals 1, 2, 3, 4, sum equals 10. Complexity. Time. O(n), space, O1, step 5, search in array. Problem. Find if target exists in array. Java. Public boolean contains int I in nums, int target. For int num nums, if num equals target, return true. Return false. Example. Nums equals 2, 7, 11, 15. Target equals 7. Output equals true. Complexity. Time, O(n), space, O1. Step 6. Find index of target. Public int find index int nums int target. For int I equals 0, I less than nums length. If nums I equals target, return I. Return -1. Example. Nums equals 2, 7, 11, 15. Target equals 11. Output equals 2. Why 2? 11 is at index 2. Step 7. Reverse array. Problem. Reverse array in place. Input. 1, 2, 3, 4. Output. 4, 3, 2, 1. Java. Public void reverse. Int nums. Int left equals 0. Int right equals nums length -1. While left then right. Int temp equals nums left. Nums left equals nums right. Nums right equals temp. Left ++ right minus pattern. 2 pointers. Complexity. Time O(n), space O1. Step 8. 2 pointers pattern. 2 pointers means use 2 indexes to solve the problem. Common setup. Left equals 0, right equals nums.length -1. Used for interarray array, palindrome check, pair sum and sorted array, remove duplicates, move zeros, merge arrays. Example. Pair sum and sorted array. Input. Nums equals 1, 2, 4, 6, 8. Target equals 10. Output. True. Because 2 + 8 equals 10. Java. Public boolean has pair sum, int nums, int target. Int left equals 0. Int right equals nums.length -1. While left equals right. Int sum equals nums left plus nums right. If sum equals target, return true. If sum greater than target, else right plus. Return false. Important. This works only when array is sorted. Step 9. Move zeros. Problem. Move all zeros to the end while keeping non-zero order. Input. 0, 1, 0, 3. Output. 1, 3, 12, 0, 0. Java. Public void move zeros, int nums, int insert position equals 0. For int num to nums. If num is 0, nums insert position is num, insert position plus. While insert position nums.length, nums insert position equals 0, insert position ++. Dry run. Nums equals 0, 1, 0, 3, 12. Keep non-zero. 1, 3, 12. Fill rest with 0. 1, 3, 12, 0, 0. Step 10. Sliding window pattern. Sliding window is used for subarray or substring problems. Common clue. Maximum sum, minimum length, longest subarray, fixed window size, continuous elements, fixed sliding window example. Problem. Find max sum of subarray of size k. Input. Nums equals 215,132. K equals 3. Subarrays. 215 equals 8. 151 equals 7. 513 equals 9. 132 equals 6. Output. 9. Java. Public int max sum subarray int nums int k int window sum equals 0. 4. Int I equals 0 I to k I plus plus window sum equals nums I int max sum equals window sum. 4. Int right equals k right to nums dot length right plus plus window sum plus nums right window sum minus nums right minus k. Max sum equals math.max max sum window sum. Return max sum. Complexity. Time. O(n) space O1. Step 11. Prefix sum pattern. Prefix sum helps answer range sum quickly. Input. Nums equals 2, 4, 6, 8. Prefix. Prefix 0 equals 0. Prefix 1 equals 2. Prefix 2 equals 6. Prefix 3 equals 12. Prefix 4 equals 20. Java. Public int n build prefix sum int r.nums. Int prefix equals new int nums length plus 1. 4. Int I equals 0 I less than nums dot length I plus plus. Prefix I plus 1 equals prefix I plus nums I. Return prefix. Range sum. Public int range sum int add prefix int left int right. Return prefix right plus 1 minus prefix left. Example. Nums equals 2, 4, 6, 8. Sum from index 1 to 3. 4 plus 6 plus 8 equals 18. Prefix 4 minus prefix 1, 20 minus 2 equals 18. Step 12. Frequency count. Use HashMap when you need count. Example. Nums equals 1, 1, 1, 2, 2, 3. Frequency. 1 means 3, 2 means 2, 3 means 1. Java. Public map integer frequency count int and nums. Map integer frequency map equals new HashMap f. For int nums frequency map put num frequency map get or default num 0 plus 1. Return frequency map. Used for key top k frequent elements, majority element, duplicates, anagrams, counting problems. Step 13. Contains duplicate. Problem. Return true if duplicate exists. Input. 1, 2, 3, 1. Output. True. Public boolean contains duplicate. Int and nums. Set integer scene equals new HashSet. For int nums, if scene dot contains num, return true. Scene dot add num, return false. Pattern. HashSet. Complexity. Time. O(n) space O(n). Step 14. To sum. Problem. Find indexes of two numbers that add to target. Input. Nums equals 2, 7, 11, 15. Target equals 9. Output. 0, 1. Java. Public int to sum int nums int target. Map integer scene equals new HashMap. For int I equals 0. I like nums dot length I plus plus. Int needed equals target nums I. If scene dot contains key needed, return new int g scene get needed. Scene dot put nums I. Return new int dot 0. Pattern. HashMap. Complexity. Time. O(n) space O(n). Step 15. Best time to buy and sell stock. Problem. Find maximum profit from one buy and one sell. Input. 7, 1, 5, 3, 6, 4. Output 5. Y. Buy at 1, sell at 6. Profit equals 5. Java. Public int max profit, int data prices. Int min price equals integer max value, int max profit equals 0. 4. Int price prices. If price equals min price equals price. Int profit equals price minus min price. If profit greater than max profit equals profit. Return max profit. Pattern. Track minimum so far. Complexity. Time, O(n). Space, O1. Step 16. Maximum subarray. Problem. Find maximum sum of a contiguous subarray. Input. -2, 1, 3, 4, -1, 2, 1, -5, 4. Output. 6. Y. 4, -1, 2, 1 equals 6. Java. Public int max subarray, int nums, period. Int current sum equals nums 0. Int max sum equals nums 0. 4. Int I equals 1, I less than nums length, I plus. Current sum equals math max, nums I, current sum plus nums I. Max sum equals math max sum, current sum. Return max sum. Pattern. Kadane's algorithm. Complexity. Time. O(n). Space. O1. Step 17. Sort array. Java. Arrays.sort nums. Example. Int n nums equals 5, 1, 4, 2. Arrays.sort nums. System.out.println arrays.toString nums. Output. 1, 2, 4, 5. Complexity. Time. O(n) log end. Use sorting for duplicates, intervals, two pointers, ranking, frequency problems, greedy problems. Step 18. Binary search in array. Binary search works on sorted arrays. Java. Public int binary search, int a nums, int target. Int left equals 0. Int right equals nums.length minus 1. While left equals right. Int mid equals left plus right minus left divided by 2. If nums mid equals target, return mid. If nums mid integer, left equals mid plus 1. Else right equals mid minus 1. Return -1. Complexity. Time. O log n. Space. O1. Step 19. 2D array. 2D array is like a table. Example. Int n matrix equals 1, 2, 3, 4, 5, 6, 7, 8, 9. Visual. 1, 2, 3, 4, 5, 6, 7, 8, 9. Access. Matrix 0, 0 equals 1. Matrix 1, 2 equals 6. Matrix 2, 1 equals 8. Traverse 2D array. Public void print matrix. For int row equals 0. Row less than matrix.length. Row plus plus. 4. Int call equals 0. Call equals matrix row.length. Call plus plus. System.println matrix row call. Common 2D array problems. Search 2D matrix. Number of islands. Rotate image. Set matrix zeros. Spiral matrix. Flood fill array. Complexity cheat sheet. Operation complexity. Access by index O1. Update by index O1. Search unsorted array. O(n). Search sorted array with binary search. O log n. Insert at end if space. O1. Insert at beginning. O(n). From beginning, middle. O in sort. O in log n. Traverse O(n). Array problem pattern cheat sheet. Problem clue pattern. Pair sum HashMap. 2 pointers. Duplicate HashSet. Frequency HashMap. Top K HashMap plus heap bucket sorted array. Binary search. 2 pointers. Contiguous subarray. Sliding window. Kadane. Range sum prefix sum. Maximum profit. Track min max. Move elements. 2 pointers, matrix, grid, BFS, DFS, nested loops, debugging arrays, step by step. When debugging array problems, print index, current value, important variables, array, state. Example 4. Int I equals 0, I less nums.length, I plus, system.out.println, I equals I plus nums I plus current sum plus current sum. Ask 1. Am I starting at the correct index? 2. Am I stopping before nums length? 3. Am I using nums length -1 for last index? 4. Am I updating variables correctly? 5. Am I handling empty array? 6. Am I handling one element? 7. Am I handling duplicates? 8. Am I handling negative numbers? Common beginner mistakes. 1. Index out of bounds. Bad. 4. Int I equals 0, I equals nums length, I plus, system.println, nums I. Problem. I becomes nums length, which is outside array. Correct. 4. Int I equals 0, I equals nums length, I plus, system out println nums I. Wrong. Last index equals nums.length. Correct. Last index equals nums.length -13. Bad. Int max equals nums 0. If array is empty, it crashes. Better. If nums equals null or nums.length equals 0, throw new illegal argument exception. Array is empty. 4. Returning value instead of index. ToSum asks for indexes. Wrong. 2, 7. Correct. 5. Using nested loops when HashMap works. Bad for large input. O of n squared. Better. O of n. Using HashMap or HashSet when possible. 6. Modifying array accidentally. Sorting changes original array. Arrays.sort, nums. If original order matters, copy first. Int end copy equals arrays.copy of nums.length. Arrays.sort copy. Corrections. Remember indexes start at 0. Last index is length -1. Always test empty and one element arrays. Use normal for loop when index matters. Use enhanced for loop when only value matters. Use HashMap for frequency, count, index lookup. Use HashSet for duplicates visited. Use 2 pointers for sorted pair problems. Use sliding window for subarray problems. Check. Use prefix sum for range sum problems. Check. Use binary search only on sorted monotonic data. Check. Do dry run before coding. Check. Print index value while debugging. Check. Analyze time and space complexity. Array interview questions. 1. What is an array? An array is a data structure that stores elements in order using indexes. 2. What is the first index of an array? 0. 3. What is the last index of an array? Array.length -1. 4. What is time complexity of accessing array by index? 1. 5. What is time complexity of searching an unsorted array? O(n). 6. What is time complexity of binary search? O log n. But array must be sorted. 7. What is the best data structure to detect duplicates? HashSet. 8. What is the best data structure for ToSum? HashMap. Because we need. Number means index 9. When do you use sliding window? Use sliding window for contiguous subarray or substring problems. 10. When do you use prefix sum? Use prefix sum when you need fast range sum queries. 11. When do you use 2 pointers? Use 2 pointers for sorted arrays, pair problems, reverse, and in-place movement problems. 12. Can array size change in Java? No. Java array size is fixed after creation. For dynamic size, use array list integer list equals new array list integer. Learn. Create array, create access index, create update value, loop through array, find max min, sum array, search value. Practice. find maximum, find minimum, find index, sum of array, reverse array, intermediate level. Learn. HashSet, HashMap, sorting, 2 pointers, sliding window, prefix sum, practice. ToSum, contains duplicate, move zeros, best time to buy and sell stock, maximum subarray, advanced level. Learn. Check binary search, check heap, check bucket sort, check Kadane's algorithm, check matrix traversal, check 2D grid DFS BFS. Practice. Top K frequent elements. Product of array except self-search in rotated sorted array, search 2D matrix, number of islands, 30-day learning plan, week 1, array basics. Learn. Index, length, traversal, max, min, sum, search. Practice. Find max, find min, reverse array, find target index, week 2, HashMap and HashSet. Learn. Check duplicate detection, check frequency count, check complement lookup, index mapping. Practice. Contains duplicate, ToSum, top K frequent elements, majority element, week 3, array patterns. Learn. 2 pointers, sliding window, prefix sum, sorting. Practice. Move zeros, max sum subarray of size K, best time to buy and sell stock, valid palindrome, week 4, interview array problems. Learn. Binary search, Kadane's algorithm, 2D arrays, matrix traversal. Practice. Binary search, maximum subarray product of array, except self-search, 2D matrix, rotate array, real-world use cases, backend development. Arrays or lists are used for API response lists, user IDs, product IDs, order items, search results, batch processing. Example. List of long product IDs equals list of 101L, 102L, 103L. Database results. Repository returns list-like data. List product products equals product repository dot find all. Then you may transform list product response responses equals product stream. Map this to response to list. Batch processing. Read records, process records in chunks, store results. Arrays lists help process multiple records efficiently. Must know array problems. 1. ToSum. 2. Contains duplicate. 3. Best time to buy and sell stock. 4. Maximum subarray. 5. Move zeros. 6. Product of array except self. 7. Top K frequent elements. 8. Search insert position. Binary search 10. Merge sorted array 11. Rotate array 12. Find minimum in rotated sorted array 13. Search in rotated sorted array 14. Subarray sum equals K. 15. Maximum product subarray. Arrays are one of the most important data structures for beginners and interviews. Important concepts. Index, length, traversal, access, update, search, sorting, 2 pointers, sliding window, HashMap, HashSet, HashSet. Key idea. Array problems are mostly about choosing the right pattern. Use. HashMap means lookup, count, index. HashSet means duplicates. 2 pointers means sorted reverse move. Sliding window means subarray. Prefix sum means range sum. Binary search means sorted search. 4 interviews. Start with brute force. Then optimize using the right data structure or pattern. Explain time and space complexity.